Well, hey guys, it's Mr. T again, and we're continuing to work on this first section. And got cut off on the previous section on number 16. I'm trying to finish that up, and then we're going to do 17 through 20. Okay, so let me close this down, and hopefully we can finish this guy off. Now, here is the end of 16. We were all the x-intercepts. There's only one y-intercept. Talked about that's when the frame of the trampoline, the floor there. Okay. And then the intervals in which it's positive is talking about from take those x-intercepts that we use, those two, okay? And so for the x-intercept is from here to here, that's where it's positive, and then from the next one to the next one, that's where it's positive, and so on. And it's negative in between them, and so that's where it came down here. But I want to talk about the negative section because I almost missed it, okay? So from 0 to 0.05 is negative, but so is this point to this one here. So that's a 2.25. And I forgot to put that one in at first. So there's 4 of those there. And then the negative is where it's below the frame. You got to do some calculating, some points there. You got to do a little bit working on that, and average speed upwards in this case. So let's go on to our next question. So let's get into this, finish this up. 17. Okay. The linear function, distance in miles, T leave from the library, sketch the graph of the function, write the domain in inequalities. Okay, where the intercepts of the graph, explain the meaning of the intercepts in this context. Okay, so if you put that mx plus b, that's -5 for the slope and 6 for the y-intercept. So I guess we get to start with negative. We said 6 for the intercept and -5 for the slope. That means come down 5 over 1. Click again. So that's 1, 2, 3, 4, 5 over 1. So it's a -5 slope with a y-intercept of 6. Okay, let's hit save, and let's make sure you get that out. So they did 6 and 5t, but mx plus b would make the 5 goes first. So it's a -5 slope with a y-intercept. And again, you can put that in a graph and calculator if you like, but if you pay attention to some stuff, you can do things faster. But you'll figure it out one way or the other. That's all right. We'll get better at it, even if you're not great today. All right, domain. In this context, okay, distance traveling from the home. Distance traveling. Can you travel negative distance? Can't travel negative distance. Okay. Type the inequality using t as the variable. Okay. So we don't use x and y. We're going to use t. The domain of t in this context is t greater than or equal to 0, because we can't go backwards in time. Let's see how we do with that. And notice it says inequality. So we're using the inequality notation. It says it does not like that. Well, this is distance from home is starting off at 6, and you're getting closer and closer and closer. But the time's going forward, but the distance from there is going closer. But the domain being t. Oh, okay. Apparently, we're going to go from 1, because I guess when you get to the house, it stops, right? 1.25 maybe. And it says use integers or fractions for numbers of inequalities. Okay, so let's start over here. We go 0, less than or equal to t, less than or equal to 5/4, because that's 1 1/4 is 5/4. Let's see what happens. It did not like that. Okay, so obviously I'm missing something. So let's look at an example. Okay. That's just like what we did with the slope and the intercept. Okay. Okay, so they got a second point, and that's how they did it. So, all right. So what are they going to do with that weird x-intercept? So apparently, we just got the wrong number. Okay, so I guessed wrong. All right, I guessed. All right, so this is what we're going to do to fix this problem, okay? And what I'm going to do here is I'm going to take this equation and say, ooh, that's way too big. So this, I'm going to say y equals 6 minus 5t. And we're going to put where y equals 0 right here. So let's solve this equation. So we're going to subtract 6 on both sides. So it's going to give us negative 6 equals negative 5t. Oh, okay. Negative 5. So therefore, t equals 6 over 5. So we needed to make this 6 over 5. Let's see if it likes that. So I just kind of guessed because I wasn't sure where to go with it. So I made a bad guess and paid for it. I think it's a pretty decent guess, though. All right, let's see if our program likes us a little better. Yes, it likes us better now. Okay, and the range is going to be from 0 to 6 for us, right? From 0 to 6. Okay, and I think I'm going to leave that alone from there. Especially with the video I've already done with the other example. It was a good example. Walk through, you can do it yourself. That gives you an idea. Graph function, state the domain and range and intervals on which function is increasing, decreasing, or constant. Okay. So graph A, the domain is all real numbers using interval notation. Oh my goodness, that's a lot of parts. But absolutely, you should be able to do that. Absolutely. I'm not going to go through all those parts. Remote control car. Okay, the domain and range of the inequalities. So the x values are going to be their domain. The y value would be the range. So it's going to be from 0 to 10. Okay, 0 to 10. Okay, select the correct choice below and fill in answer boxes for your choice. And it says, oh, so we're doing the domain first. Woo, I was going to get ahead of myself here. Said like that. Now it should ask the range. And the range is 2 to 10. 2 to 10. Let's look for a y with something on both sides. So there's a 2 and a 10. And let's check it like that as well. Okay. The x-intercept, select the correct choice below. And okay. Now, I got a sneaking suspicion that they're wrong about their. So in this case, there is no x-intercept about how they want you to write it, but there is no x-intercept. It does not cross the x-intercept at all. Distance from the wall. So it was traveling away from the wall and then turned around and started heading back to the wall. Okay. So which one of these says that? Okay. The distance from the wall was 0, and then it went up to 8, and then down to 4. The car touches the wall. Zero seconds since it started moving. Yeah. Its maximum distance from the wall was 8, but not its minimum. So I'm going to say the wall 0 seconds. Touches the wall 0 seconds since it started moving. And once it started moving, never touched it. Weird. So let's give it a 0. See what it thinks. No. What does the x-intercept say about the motion car? Well, obviously I don't understand the question. Motion car moves toward a wall, stops and backs up. Oh, okay. It's going toward the wall, not going the other direction. And y'all are just saying that. You didn't read it correctly. So there you go. So the minimum distance from the wall is 2 inches because it almost made it there. See if it likes that better. Try again. Didn't like that either. Oh, well, Okay, we never know. Okay, it never touches the wall. But even though we're going to go that one. All right. All right, what's the y-intercept? Oh, it says, oh, and notice it says type an ordered pair. So it's wanting 0, 10. 0, 10, even though the y-intercept is officially 10, but it wants an ordered pair. Well, that is officially incorrect, but we're going to go with it. Whew. And then lastly, 20. Okay. So let's look at this. It says the interval average rate of change on 0 to 4. So from 0 to 4, what's the average rate of change? So we're going to use the 2 points, 0, 12, and 4, 4. Okay, and then it says 6. And then so let's go 6, 4, and then 10, 10. So we can do the average rate of change of the black ones and the average rate of change of the blue ones. And all right, I'm done. I think I have done more than enough to get you on the right track. You still might have to struggle through a few of these, but that's part of the deal. All right. Okay, we made it through the first one. Woo! Good luck. As always, hope that was helpful.